3 in the morning, production incident, and someone does the thing we've all done. He's in, runs kube control edit, and hand patches the cluster to stop the bleeding. It works. The alert clears. Everyone goes back to bed. And 30 seconds later, the cluster quietly undoes the fix, all by itself, and puts back exactly what was there before. Not a bug, a feature. That's a cluster running GitOps. And that self-correcting behavior is either the most reassuring or the most infuriating thing you'll meet in modern infrastructure, depending on whether you understand it. Welcome back to DevWise. Today, GitOps, the deployment model that's become the default for serious Kubernetes, why your cluster should fix itself, and how the two big tools, Argo CD and Flux, actually work. By the end, that self-healing cluster will feel like a superpower, not a haunting. Let's begin. Let's define it cleanly, because GitOps gets thrown around loosely. GitOps is a way of operating infrastructure, where Git is the single source of truth, and an automated agent continuously makes reality match what's in Git. Break that into its two halves. First, everything about your system's desired state, which apps, which versions, how many replicas, what configuration, is declared as files in a Git repository, not typed into a console, not applied by hand, declared in version control. Second, an agent running inside your cluster watches that repository and continuously reconciles. It compares what Git says should be running against what's actually running, and if they differ, it changes reality to match Git, not the other way around. That second half is the heart of it, and it flips the traditional model. In the old world, you pushed changes at your cluster, a pipeline ran kube control apply, or Helm, and shoved new state in. In GitOps, the cluster pulls its own desired state from Git and applies it itself. This is called pull-based delivery. And it's not a small detail. It's the foundation of nearly every benefit we'll cover, from security to self-healing. Here's the mental model that makes it click. Think of Git as the blueprint and the GitOps agent as a tireless building inspector who walks the site every few minutes. Blueprint says 3 floors. The inspector sees 3 floors. Fine, move on. Someone sneaks in overnight and adds a 4th floor by hand. Next round, the inspector notices the mismatch and tears the 4th floor back down, because the blueprint is the truth and the building must match it. That's reconciliation. That's your cluster reverting the 3 a.m. hotfix. And that leads to the single most important rule in GitOps, the one that reorganizes how you work. You never change the cluster directly. You change Git. Want to deploy a new version? Commit it. Want to scale up? Commit it. Want to roll back? Revert the commit. The cluster is downstream of Git, always, and once that clicks, everything else follows. GitOps didn't become the default because it's fashionable. It won because it solves 4 expensive recurring problems at once. Let's take them in order of how much pain each removes. Benefit 1. Auditability, for free. Because every change is a Git commit, you get a perfect, permanent history of your infrastructure. Who changed what, when, and why, with a diff and a pull request discussion attached. No separate change management system. Know who deployed this mystery at 3 a.m. Compliance and security teams love this more than almost anything, because your entire operational history is already a signed, time-stamped, reviewable record. Auditing becomes reading Git log. Benefit 2. Rollback is a Git revert. This one changes how incidents feel. A bad deploy in the old world means a panicked scramble. Which version was good? Redeploy it. Hope. In GitOps, you revert the commit. The agent notices the change and rolls the cluster back to the previous known good state, automatically, the same safe path every other change takes. No emergency SSH session, no hand-rolled rollback script. Your worst deploy becomes a one-line undo. Benefit 3. Drift elimination, the self-healing from our cold open. Configuration drift is the slow rot that kills long-lived environments. Someone makes a manual tweak, forgets to document it, and now your cluster no longer matches anything in version control. Multiply that over months, and nobody knows what's actually running. GitOps kills drift at the source. Any manual change gets detected and overwritten on the next reconcile. Your cluster can't rot because it's continuously dragged back to match Git. That's why the hotfix reverted. It was drift, and the agent did its job. Benefit 4. A genuinely better security posture. This is the subtle one, and it comes straight from pull-based delivery. In push-based CI/CD, your pipeline needs powerful credentials to reach into the cluster and change things, so your CI system holds the keys to production, and, if it's compromised, so is your cluster. In GitOps, the agent lives inside the cluster and pulls. Nothing external needs cluster admin credentials. Your CI system just writes to Git. The blast radius of a compromised pipeline shrinks dramatically. It can write a commit, which a human still reviews, not reach in and delete your production namespace. 4 benefits. 1 mechanism. Declarative state in Git, reconciled by a pull-based agent, and auditability, easy rollback, no drift, and tighter security all fall out of that single design. That's why, by 2026, GitOps stopped being a nice-to-have and became how serious Kubernetes teams simply operate. Let's slow down and watch the reconciliation loop itself, because understanding this one cycle is understanding GitOps. Everything else is detail hung off it. The loop has 4 steps, repeating forever. Observe, the agent reads the desired state from Git and the live state from the cluster's API, diff. It compares them. Act. If they match, it does nothing and waits. If they differ, it applies whatever's needed to make the cluster match Git. Repeat. A few minutes later, it does the whole thing again. That's it. A patient, endless cycle of does reality match the blueprint? If not, fix it. The states you'll live with come straight from this loop. In sync means live matches Git, the calm, green, steady state. Out of sync means they've diverged. Maybe you just committed a new version and the agent hasn't caught up, or maybe someone made a manual change. From out of sync, the agent either syncs automatically or waits for you to approve, depending on how you've configured it. That configuration choice matters, so let's name it. Automated sync means the agent applies changes the moment Git differs. Fast, hands-off, ideal once you trust your pipeline. Manual sync means the agent detects the difference and flags it, but waits for a human to click sync, useful for production environments where you want a person in the loop before anything touches the cluster. Many teams run automated sync in dev and manual in production, and that's a perfectly sensible place to start. 2 more controls worth knowing, because they're where teams get surprised. Self-heal, when enabled, is what reverts manual changes. Turn it off, and drift is detected but not corrected, which is sometimes what you want during an incident. And pruning, when you delete something from Git, does the agent delete it from the cluster? Only if you've enabled pruning, otherwise, removed from Git resources, linger. These 2 switches, self-heal and prune, are the difference between Git is advisory and Git is absolute law, and knowing which mode you're in is the difference between calm and confusion at 3 a.m. One last piece. How does the agent know Git changed? 2 ways. Polling. It checks the repository every few minutes on a timer, simple and reliable. Or webhooks. Git notifies the agent the instant a commit lands, for near-instant deploys. Most teams use polling as the dependable baseline and add webhooks when they want speed. Either way, the loop is the same, only the trigger differs. 2 tools dominate GitOps, and by 2026 the choice between them is one of the more common architectural decisions a platform team makes. Both are cloud-native Computing Foundation graduated projects, the Foundation's highest maturity tier. Both are battle-tested at massive scale, and both implement the exact same pull-based model. They just embody opposite philosophies. Let me give you the honest comparison. Argo CD, created at Intuit, is the market leader, running in roughly 60% of GitOps clusters, with about 23,000 GitHub stars on its 2026 releases. Its defining feature is a rich built-in web dashboard. You see every application, its sync status, a live tree of every Kubernetes resource, and a visual diff between what's in Git and what's running. And you can trigger a sync with a click. Argo CD is, in one community summary, a product for your developers. If your team includes people who want to see deployment state in a browser rather than a terminal, developers, stakeholders, on-call engineers scanning quickly, Argo CD is the lower friction path. It also shines at multi-cluster management from a single pane of glass, with the application set controller generating hundreds of apps from templates. Flux, originally from Weaveworks and now maintained by engineers at AWS, Microsoft, GitLab and Cisco, takes the opposite approach. It's a set of lightweight Kubernetes controllers you assemble like building blocks, the GitOps toolkit, with no built-in UI, driven by CLI and YAML. That community summary calls Flux an engine for your platform. Flux is leaner, deeply Kubernetes native, has excellent built-in image automation and first-class customize and Helm support, and tends to win at very large scale, hundreds or thousands of clusters, where its smaller footprint and pure API-driven model shine. If you refuse to add a human-facing control plane to your security model, Flux's discipline appeals. A quick, honest note on Flux's history, because you'll hear it raised. Weaveworks, its original company, shut down in early 2024. It's a non-issue now. Major cloud vendors hired the maintainers, Flux kept its CNCF graduated status, and it ships steady releases to this day. Both tools are healthy and here to stay. So which do you pick? Here's the clean rule. Choose Argo CD if you value a visual dashboard, want the easiest onboarding, or have a mixed audience of developers and operators. It's the safe default for most teams starting today. Choose Flux if you prefer everything as code with no UI, run at very large scale, or want the leanest possible Kubernetes native footprint, and you genuinely cannot go wrong. The best move is to trial both against a non-critical workload and see which operational model fits your team's hands. Let's make it concrete with the market leader, Argo CD. The shape is nearly identical in Flux. Watch how little there is once you understand the loop. First, install. You create a namespace and apply Argo CD's manifests, one command, and the controllers, the API server, and the dashboard are running in your cluster. That's the whole install. Next, you tell Argo CD what to watch with an application manifest. This is the key object, and it's beautifully simple. It says, here's a Git repo, here's the path inside it, here's the cluster and namespace to deploy into, and, crucially, the sync policy, automated, with self-heal and prune both on. That single block is you declaring keep this namespace, exactly matching that Git path. Forever, revert manual changes, delete what I remove. You apply this manifest once. From here on, you never touch the cluster again. Now the payoff. How do you deploy version 1.9? You change the image tag in a file, commit, and push. That's it. That is the entire deployment. Argo CD notices the repo changed, shows the app as out of sync, and, because sync is automated, pulls the new manifest and rolls it out, updating the dashboard as each resource goes healthy. No pipeline reaching into the cluster, no kube control, no credentials handed out. A Git push, reviewed by a teammate, is your deployment. And rollback? You already know it. Git revert that commit, push, and Argo CD rolls payment service back to 1.8.2 the same way it rolled forward. The mechanism that deploys is the mechanism that recovers, which is exactly why GitOps teams sleep better. Now the honest part, because the production Bible demands it, and because these are the exact places teams stumble. GitOps is powerful, but it has genuine sharp edges, and knowing them ahead of time is the difference between loving it and fighting it. First, secrets. You declare everything in Git, but you absolutely cannot commit a plaintext database password to a repository. So how do secrets live in a world where Git is the source of truth? The answer is encryption or references. Tools like sealed secrets and SOPs let you commit an encrypted secret that only the cluster can decrypt. Or you reference an external secrets manager and let an operator inject the real value at runtime. Either way, Git holds a safe, encrypted, or indirect reference, never the raw secret. This is the first wall every GitOps team hits, and it has well-trodden solutions, but you must plan for it, not discover it. Second, in sync does not mean healthy. This trap catches people. Argo CD showing green means the cluster matches Git. It does not mean your application actually works. You can perfectly sync a manifest that deploys a broken image that crash loops forever. Sync status is about agreement with Git. Health is a separate question. This is exactly why the last 2 episodes matter here. GitOps tells you the deploy matched intent. Your observability tells you whether that intent was any good. They're partners. Third, repository sprawl and structure. With everything in Git, you now have a very important decision most teams underweight. How do you structure your repos? One giant monorepo or many small ones? How do you separate dev, staging, and production? How do you promote a change from one environment to the next? Get this right, and GitOps scales gracefully. Get it wrong, and you drown in copy-pasted YAML and merge conflicts. There's no single correct answer, but there is a wrong one, not deciding deliberately and letting structure grow by accident. And a fourth, quieter one. GitOps governs state beautifully, but it isn't your whole pipeline. You still need CI to build and test and produce the image. GitOps takes over at delivery, the clean division. CI builds and writes to Git. GitOps deploys from Git is the pattern that works. Blur that line, and you lose the very benefits you adopted GitOps for. Let's land it with the habits that make GitOps a genuine superpower rather than a confusing new way to break production. 1. Never change the cluster directly. Change Git. This is the whole discipline in one sentence. The moment someone bypasses Git with a manual kube control, you've reintroduced drift and lost your audit trail. Make Git the only door in. 2. Turn on self-heal and prune deliberately, and know which mode you're in. These 2 switches decide whether Git is advisory or absolute. Choose consciously per environment, and make sure your team knows most 3 a.m. confusion is someone forgetting self-heal is on. 3. Solve secrets before you scale, not after. Pick your approach, sealed secrets, SOPs, an external manager. On day 1, it's the first wall. Walk through it deliberately rather than face first. 4. Monitor sync and health as 2 different things. Green sync plus a crash-looping pod is a real, common state. Pair GitOps with real observability so you know not just that the deploy matched Git, but that it actually worked. 5. Design your repo structure on purpose. Decide mono-repo versus multi-repo and how environments promote before the sprawl decides for you. A little architecture up front saves a year of your mail pain. Master those, and GitOps stops being a spooky cluster that undoes your work and becomes what it truly is, a calm, auditable, self-correcting system where every change is reviewed, every deploy is a commit, and every rollback is a revert. Your infrastructure, finally, behaving like well-managed code. That's GitOps. Git as the source of truth, the reconciliation loop, why it won, Argo CD versus Flux, a real setup, and the sharp edges to plan for. Adopt it well, and your cluster stops being something you fight and becomes something that quietly keeps itself correct while you sleep. If this earned its 20 minutes, a like genuinely helps the channel reach more engineers, and subscribe for more calm, practical guides for the people who keep production running. Plan before you apply. Goodbye for now.